Okay, so let's start now. Sheena is here. Okay, so this chapter, right, we have completed some parts of it the last lesson. So we are continuing with this part here. So last lesson, we talked about contact forces, non-contact forces, etc. Right? So this one is focused on pressure. Are you able to see my slides? Can? Okay, good. Thank you. Right, so let's start. When you talk about pressure, maybe some of you have learned this part already. How many over here you have come across this term? You have already gone through, lectures in school or lessons in school talking about pressure. Put out your hand if you have. Okay, Birkin, you have, right. Harvard as well, Janelle. So some of you, your school started this topic and going quite fast. Okay, I think it's because your school wants to finish this soon, and then, can do a lot more revision at the end of towards the next half of the year, because you need to revise that one topic also. Now, so quickly, pressure. When we talk about pressure, it's not like the stress that you have in school. Okay, it's not that kind of pressure that you face. Okay, it is more like, in the physics terms, it's the force that's acting on an object per unit area. Okay, so this force must be acting, in a direction that is perpendicular to that of a surface. Okay, so pressure depends on the applied force. There is a certain formula and it's given here in the slide. P equals to F over A. So this is actually applied force over the area, the surface area it is in contact with. Okay, so mathematically, this is the formula. All right, so always we will be referring to this formula, especially for today's lesson. If there is enough time, I will be showing you some common exam questions that you can see in exam papers. Okay, pressure will increase if, let's say, the force increases or let's say the area decreases. It's quite simple if you were to look at this formula. Now, if you have a bigger force, that means this value here will be greater. When this value here is greater and divided by the same surface area, of course, the pressure is greater. Then it can also happen where the force stays the same, but the area becomes smaller. Imagine, okay, me, all right, stepping on your hand, which is on the floor, when I'm wearing track shoes, compared to when I'm wearing high heel shoe, okay? So my force is my weight. So this is the weight of my landing on your hand, either via the track shoe or high heel shoe. Which one is more painful? Definitely the high heel shoe, because the area of contact is smaller. So all the force is applied to that small little area. Yeah, you can break your hand very easily. Okay, because the pressure is great. Now, SI unit for pressure is Pascal, or you can use Newton per meter square or Newton per square meter. Now, SI unit will be this, okay, Newton per square meter. But many times in the question, they even talk about the area being in, square centimeter. Follow the question accordingly to what is being asked you to do. All right. Now, so again, this is like repeated. So you have a force acting on a small area, you get a great pressure. Okay, because all the force, like the high heel shoe example, all the force will be concentrated at the very small area. Now, if you were to look at this diagram here, okay, so this is the nail. Okay, so when you are applying a force, let's say you use a hammer to hit the nail, because the nail is sharp right at the end. Okay, so the small area here will allow it to actually penetrate the wall easily. Okay, next. So this is the good reason why we use sharp objects for cutting, for sawing, for hammering. Okay, pressure is very low when the force is spread over a large area. Now, can be easily determined also by some calculation, right? So due to the decreased pressure, area of the object must be increased. Now, low pressure is useful for moving on soft soil or snow, even for quicksand, right? Let's say you are in this area where there is quicksand. If you are standing upright, it's very easy for you to really go in. But if let's say you are lying down, okay, the time taken for you to move into the quicksand will actually be longer. Yeah. longer time will be required. Right, so this is just an example here. Okay, you will notice that I'm going through a little bit fast because by right, you should have already read your textbook, watched the video in the e-learning portal, tried the question, and then come prepared, right? Okay, so this part here, I'm not going to spend a lot of time to teach, more like a summary. Right, so if you look at this particular picture here, you can see that, skis have large surface area, so the skier doesn't sink into the snow. Then another example, camels, okay, they have large padded feet. Okay, so they don't actually sink into the sand easily. Okay, snowshoes also, yep, you have the large flat soles, right, to reduce pressure on the snow so that the person does not sink into the snow. Right, so I mentioned just now, if your area remains the same, a greater force must be applied in order to get a greater pressure. So far, so good. Okay, then this is the last part, atmospheric pressure. Right, so this is the notes given to you. Okay, Earth is surrounded by a layer of air. Okay, when the layer of air exerts pressure on us and all objects on Earth, atmospheric pressure arises. Okay, this part here is extra info for you. So far, I have not really come across question asking this. Okay, but it's good info for you to know. Okay, atmospheric pressure changes with respect to the height above the sea level. So the higher the level, the lower the atmospheric pressure. Okay, so the higher the sea level, that means the lower the atmospheric pressure. If the atmospheric pressure is higher, then the sea level will be lower. Okay, yeah. So I will leave this to you to read on your own. Okay, I will rather focus more on what is going to be tested over here. Okay, and the worksheet questions I want to go through with you first before I come back to this part to discuss further. All right, so last week I spent a lot of time actually going through the notes. So this lesson, I will actually cut down a bit and focus more on the questions, more examples to be brought in. I think that's more useful for all of you. All right, so let's go into our worksheet now. Let's see. Okay, so these are actually the things that you will learn for this topic. We are still at the beginning part, right? So question 1 is quite simple, quite direct. Okay, if you have already gone through my lesson last week, you should know that, gravitational force are acting on an object, okay? That is actually weight we are talking about. Mass is what is contained inside our body, right? And then the gravity pull will determine our weight. So that means if you are 20 kg, all right, that is your mass. Okay, your weight will then be multiplied by the pull of gravity, and that is actually 10. In upper secondary, you are not going to learn it as 10. It's going to be 9 point something something. Okay, not telling you now, but lower secondary, you just stick to 10. Okay, so when you are talking about your weight, 20 kg is your mass, your weight will be 200 newtons. Yeah, so we have gone through this one as well. So this is weight, 1C. Okay, all of you got it correct. I think someone, probably it was an error or careless mistake. Now, question 2 here. Yeah, only 2% made a mistake here. Now, you have to look for the statements that is not correct about force. Okay, so force, take a look at the first one, measured in Newton. Okay, this is the unit that is correct. Now, and then the 100-gram object exerts a greater force than 50-gram object on your hand. Okay, so if you want to convert it to force, yeah. First, you have to change this to kg, right? 0.1 kg, then you want to convert it to weight. Okay, that will be 1 Newton. And if this is the 50-gram, then of course it's half of that, 0.5 Newton. Obviously, yeah, exerts a greater force on your hand. Okay, now changing the shape of a plasticine model is the effect of a force. True. Okay, what are the effects of forces? This is one of it. It can change the shape. It can change even the direction of movement. It can cause a stationary object to move. It can cause something that's moving to stop. So changing the shape, yes, is effect of a force. Now, it is always acted in the horizontal direction only. Can you explain to me why this is not correct? I would like to see your responses in the chat. Okay? Why is this not correct about forces? Okay, LeBron, I see your response here. Okay, yeah. Wesley, I'm asking for reasons why D is our answer here and why D is not correct about forces. So you have to explain now, not tell me answer is D. Yeah. Yeah, because it said only in the horizontal direction. Now, a very obvious example will be gravity pull, right? It's a vertical pull. Yes. Thank you, Sheena. Yeah, it can be a downward force. Yeah, vertical pull. So this is obviously not correct. Yeah, horizontal only. So some of you said, yeah, the word only is a giveaway. Usually when you have question with the options that state only, that will not be our answer. That will be something that is not true. Okay, but in this case, we are looking out for a statement that's not true and it's 2D. Okay, so gravity is a vertical pull. Yeah, forces can actually be exerted in all directions. That's true. Right. Question 3, very straightforward. Everybody got this right. Yeah. Okay, so two identical blocks A and B, they are being pushed across two different surfaces as shown. Okay, ice surface and then a rough wooden surface. Which of the following is correct? Is very easy. It's a giveaway. Questions like these can come up for exam. Usually about maybe 30 to 40% of the question will be this kind of very direct, straightforward kind. Yeah, for you to score certain marks, yeah, and to help everybody to pass. Okay, so obviously block A requires lesser force and block B to initiate its movement because this is a smooth surface. There is actually lesser friction in between, A and the ice surface compared to, the friction between B and the rough wooden surface. Okay, so quickly, let's go on to question 4. Question 4, okay. Which of the following statements is not correct about magnetic force? Okay, magnetic force, we know that it can be pull or a push. So attraction or repulsion is correct. Yep, non-contact force, yep, it can act at a distance also. Every object which has mass can attract or repel another object which has mass also. What is this statement talking about? Do you all know? Those of you who know, type it into the chat. Okay, when you see these particular statement, every object which has mass can attract or repel another object which has mass also. We have seen something similar like this, yeah, but we don't talk about, yeah, Harvard, you're right. We talk about gravitational force, right? But we don't talk about repel. We only talk about attract. So it was a similar statement we have seen related to gravitational force, but not repulsion. Right, not Harvard? You recall that, huh? Good. So the strength of the force depends on the distance from the magnetic substance. The strength of the force depends on the distance. Okay. The strength of the force depends on the distance from the magnetic substance. Okay. Yep, of course. Okay, so this one is like if I have magnet 1 cm away from the paper clip compared to the magnet being placed 5 cm from the paper clip, of course, you know that the strength of the force, okay, will be stronger when it's closer to the paper clip. So it depends on the distance. So this is the one that is not true about magnetic force.